Oh, so we're recording here. Let me pause for a second. I need to make sure. Okay, so let's go ahead and continue on with experiment one. And experiment one, you can find under the course content area. Let's go through this real quick. It is titled Coulomb's Law. So click it one more time. You'll see a bunch of different documents show up here on the left side, and this is where you're going to be finding pretty much all the experiments for each week. And remember that this first experiment is an individual experiment. So where you see IND, it implies individual, and GRP means group. And so for this experiment, I have a little sample document up here, and um, we can look to see that along this axis here is a ratio of force over the charge squared. And along this x-axis, we have a distance r. Actually, it's 1 over r squared, which is measured in meters squared, 1 over a meter squared, with the -2 being there. And so here's the document that you're going to be looking at. So read, as it relates to the sample graph, read over this. It talks about how you should, um, I'm not a big significant figures kind of guy, so uh, I wouldn't worry too much about that. I would worry more about defining what the graphs correspond to and labeling the axes properly. So don't just go ahead blindly using some graphing mechanism to get your answers. Make sure that you um, utilize and are able to retitle these axes, because what the goal is eventually when we start doing the more expanded version of your lab reports is going to be that when somebody um, gets your document, they should be able to understand easily what it all is about. So, so this document that is the main hub for this experiment talks about Coulomb's law. You'll see that there's a quite a relationship between these two. So you've probably taken physics one, and you probably uh, worked with Newton's universal law of force, Newton's gravitational law, and it looks very much like the force associated with the charge, the force when you have two particles of various charges. And we'll get into that a little bit later. You'll put your name here, so you'll need to just type it. You'll read some theory, and you're going to go to the first simulation. So the first simulation is a PHY simulation, and let me try to pull that up. And at the same time, I'm going to split my screen. So I already have it pulled up, but I need to split the screen here. And let me make this a little bit larger so things come through properly in the recording. Okay, so what we're going to be trying to do here basically is we're going to be trying to calculate what K is. And K is essentially this big constant 1 over 4 pi epsilon naught. Um, so all this is compressed into K. This is what's called Coulomb's constant. And I give you some calculations for K here and give you what the abbreviation stands for. So at some point in your document, preferably before or near your explanation, your first exposure to these abbreviations like C, you should explain what what they mean. So C is a charge and it's measured in Coulomb. You may not have gotten into that the first week. Not sure, which class you're in. And N is a measure of force and it's measured in newtons. And so if you were to click this link, you would go to this the simulation, and I walk you through how you should set up the simulation and what you're going to be trying to do. So basically, you're going to be changing the distance between the two charges and measuring the force. And so it'll spit out the force basically for you. You can see that the force that this charge imposes on this charge is the same that the second charge Q2 imposes on Q1. And that's basically Newton's third law that says that for every action, there's an equal and opposite reaction. So for every force, there's an equal and opposite force by those two specific items or particles in this case. So you'll notice here though that the measuring device here is measured in centimeters. You're going to want to get that in meters at some point because remember, newtons are SI units, so measures of force are in SI units. So you want to stay as close to SI as you possibly can. Notice here that you're given R values, which is the distance between the two charges, are in centimeters. And so you'll have to do a little bit of calculations later on down the line over in this column. And these brackets, for the most part, throughout the semester, you'll see this. The brackets just tell us what the units are. And in this case, the units are going to be in Coulomb squared at the top. And so you'll be placing some numeric value either in a specific area or in a column, and it's understood to be in those specific units. Okay, so you don't need to repeat and write down, say, for example, in this column here, you don't need to write down, let's just say 1.74 times 10 to the, or times 10 to the second power. You don't need to write down newtons, newtons, newtons every time. It's understood to be in newtons once you define the units. Okay. So you're going to also have to create a plot of force versus the distance R. You're going to need to title, put the axes titles with the units that you designate that you feel are proper. And you'll copy and paste that here. So you can remove this once you copy and paste it and put your plot in that area. And then down here, you'll go through some more data calculation and some more plotting, right? You use the y-axis for this calculation, and you'll use the x-axis for 1 over r squared. Remember, that was that meters to the -2 power. And if you're a little bit shaky on big R coefficients, this is the coefficient that statisticians use to see how close to a specific graph we are. In this case, we're going to try and get this to look like a line or a linear graph. So you're going to want to go through and read this or just watch this quick video here. You can copy and paste that and you'll go to that video to see what R is. And if you're really interested, you can play around on if you have a graphing calculator, one of the TI calculators, you can figure out that R value. I'm not sure if it uses big R or not, but you can play around in there. Okay. And then in table 2, you'll do something very similar. You'll go through figure out what the charge Q1, Q2 are equal to in coulombs, Coulomb squared, sorry. R squared, you'll figure out as well. This is in meters squared, so on and so forth. You'll find the average K, which is called K bar. And here you're going to find a percent error, K. And so the percent error of K, which we'll call in most of these documents, percent of delta K. And I think that's a gamma actually. And basically the calculation or the numeric value, which comes from the slope of the graph that you get, should be pretty close in line with what you'll get, what you know in theory K to be. And K is measured in, and there's a little typo here, K should be measured, and gave it up here. We can also measure it to be in newtons meter squared divided by Coulomb squared. Okay. And so down here, and it's just going to be one big number as long as you're in SI units. So the number that you'll get here should be pretty close to that 9 times 10 to the 9th. And for some reason that became an F. So I think that's force over meters square, force over meter. But you can kind of disregard that for right now because that was my error. Because the units are a little mismatched from what you have here versus what you have up top, but you should still be okay because those units, force divided by meters, are going to correspond to what you have up above in terms of the coulombs and newtons, so on and so forth. But the key is that if this percentage error, this percentage of gamma K is off significantly more than, let's just say, I would say you shouldn't get an error of more than, I'd say 10%. If you get an error upwards of that, you've probably done something wrong and you need to repeat the experiment. Okay. So these numbers should be pretty close. And if you're off significantly, start the process over again. Right. You shouldn't be off by more than the factor of 10 overall. If you're off by a factor of 10, that means you're off roughly by it could be potentially 100%. So you shouldn't get any errors that high. And this is our check, right? And then finally, in this last part 2, it's going to ask you, we're going to ask you some questions. And so make sure you answer appropriately here. Okay, so that is it for our first week's experiment. Good luck with it. I want to answer a couple questions that you guys asked me. And these are some common questions. Number one, am I going to be in the same group throughout the semester? Theoretically, yes, but every once in a while I'll get, some shakeup. Maybe somebody will drop a class. So I may have to rearrange you guys. I know that's a bit of a drag sometimes, but just understand that I have to keep things in balance and it's not fair for everybody. And I'll try to ask you guys if you guys want to move. I know some of you guys kind of get a cadence with the group and you know what to expect. I would say as you're working in groups, when you do these experiments, these quote unquote experiments that you perform as an individual, the experiment in total, and then circle back with your group, and then you guys kind of learn from one another. Hey, did I do this right? Did I do it wrong? Don't lean on one person to do all the work, right? You will shoot yourself in the foot. It is not good practice to do it that way. Even though you guys are working in teams, and you may divide up some of the work. This one's not probably one where you're going to want to divide too much. These experiments in total, this is one where you guys are going to need to collaborate to see, hey, am I in the right, am I doing this right? You're going to learn from one another because all this is going to come back in the final exam. So am I going to be in the same group? Um, Possibly, more than likely, yes, but every semester I don't know, what happens in each group and who's going to drop and who's going to stay in. Um, Emails. How do I email members in my group? You can email. You should be able to click the communicate tab. Let's see if I can do it here. Maximize that. So if you click communicate in class list, you should be able to see it. Every member in your group. You should also be able to click groups and see which groups you're in. I'm looking at it from the instructor side. You should be able to see yours a little bit differently. Let me pause the video here real quick and I'm going to come back and show you what it looks like from a student perspective. So, one second. Okay, so I am in as a student. Um, so I enroll myself into group one. So if you happen to see this and you're wondering why there's a person in there named demo student, it's because I didn't get back to taking them out your group. So let's see if I can do this. So if you go to communicate and I go to groups, I can see now that I am in this group and the group is for the subject of capacitance. And if I wanted to, I can email those group members. So I am in a group. I am in this section. I can see the 42 group members in the class, and I should be good to go. All right. So I think you guys should be good to go. Let me just finish answering these questions here for you guys as well. Um, Do I need to show all work? Yes, you need to show all work. Make sure it's typed. Do not submit any handwritten work. It all needs to be typed and it shouldn't be all that cumbersome. Um, the other part of it being typed, I get a lot is, do I need to show all of the calculations? No, you don't need to show all the calculations if there's a repetitive set of calculations, but you should show me one example so I can verify that your answer is either right or wrong as time to give you a grade. And those are the questions that you asked. If you guys have any more questions, feel free to email me or give me a call. My phone number is 727-791-2503. You can also use the help desk line. They're usually pretty readily available. Their number is 727, let's see, 791-2795. I believe that's it's the technical support number, and they can redirect you as necessary. So also remember, yeah, I'm still sharing my screen. You guys need to submit your lab safety sheet for the acknowledgement of attendance for the first week. So make sure you get that done. Looks like about half the class has done that, so you guys are doing just great. Um, and then now you should be able to get started for week one. Okay, have fun. You guys take care.